Asaseo. Today we'll have the continuation of solving word problems involving conic sections. For sample problem number 2, the vertices and foci of 5x squared minus 4y squared plus 50x plus 16y plus 29 equals 0 are, respectively, the foci and vertices of an ellipse. Find the standard equation of this ellipse. Alright, so for number 2, the given is a general equation of a hyperbola. So we have 5x squared minus 4y squared plus 50x plus 16y plus 29 equals 0. Now we have to rewrite this first into its standard form. So we begin by grouping the x's and the y. So we have 5x squared plus 50x and then minus 4y squared plus 16y equals, we'll use addition property of equality, so we'll add negative 29 on both sides of the equation. So plus negative 29, making this 0, and it's equal to 0 plus negative 29, that is negative 29. Now, after grouping, we'll have to complete the square. And before we do that, it's better if we factor out this coefficients first. So we have 5 times the quantity of x squared. That is from 5x squared divided by 5. So next will be 50x divided by 5. We'll have 10x plus blank. So we'll complete the square. And then minus, factor out 4 or negative 4. That will be y squared. Negative 4y squared divided by negative 4 is y squared. And then this time we have 16y. 16y divided by negative 4, that will give us negative 4y. Again, 16y divided by the number that you factored out, that is negative 4. So we'll have negative 4y plus blank, since we are completing the square. And then equal to negative 29 plus 5 times the number you add here minus 4 times the number that you'll add here. So let's write that here, plus 5 times blank minus 4 times blank. Alright, so we'll proceed with completing the square. Look at the middle term, the coefficient is 10. So divide 10 by 2. 10 divided by 2 is 5, and then multiply it by itself. So we have 5 times 5, that is 25. Meaning, on the other side, we'll be adding 5 times 25. Next, we have the middle term of the next trinomial. We have negative 4. So negative 4 divided by 2 is negative 2 times itself. That will be negative 2 times negative 2, that is positive 4. So the answer for the last term will always be positive. Okay, so here we'll have minus 4 times 4. Again, whatever you add on the right side will be added on the left side of the equation as well. Okay, so let's continue. We have here 5 times. We'll express the perfect square trinomial into the square of binomials. We have the square root of x squared, that is x. Copy the sign of the middle term, we have plus. And then the square root of 25 is 5 squared. Minus 4 times y squared, the square root is y. Copy the sign of the middle term, minus, and then the square root of the last term is, square root of 4 is 2. So squared. And then simplify this one. We have negative 29 plus 5 times 25 is 125. So next is minus 4 times 4, that is 60. So minus 16. So we'll have 5 times the quantity of x plus 5 squared minus 4 times the quantity of y minus 2 squared equals the sum of this. We may combine first the negative numbers, so that is 29 and 16, which gives us 29 plus 16 is 45. So that is 125 minus 45. Okay, and then we'll continue. We have 5 times the quantity of x plus 5 squared minus 4 times the quantity of y minus 2 squared is equal to 125 minus 45, that is 80. For the last step, we'll have to divide both sides of the equation by 80 so that this will become 1. So we have to divide these terms by 1. Sorry, this is minus. Okay, so we have 5 over 80. We can get the lowest term by dividing them with their greatest common factor. That is 5. 5 divided by 5 is 1. No need to write 1 here. And then 80 divided by 5 is 16. Minus 4 and 80, their GCF is also 4. So we divide by 4. That is 1. Again, no need to write 1 on that part. Divided by or over 80 divided by 4 is 20 equals 80 divided by 80 is 1. So this is now the standard form of the equation of the given hyperbola. This time we'll look for the vertices and the foci. Okay, so for us to find the vertices and the foci, we'll have to look first for the center of the hyperbola. And it's very easy because we can actually see it on the standard form. So h is here. You take the opposite sign, that will be negative 5. Why the opposite sign? Because remember, it's x minus h. So we'll have x minus negative 5 to get x plus 5. So next we have k with y. That will be the opposite sign. We have 2. So y minus k. Center is negative 5 and 2. So let's proceed with the value of a, b, and c. Remember, the value of a will determine the coordinates of the vertices, and then we'll be needing b as well for us to find the value of c, which will help us to look for the coordinates of the foci. So a is actually the square root of 16 because based on the standard form, 16 here is a squared. So the square root of 16 is 4, meaning a is equal to 4. And then b will be the square root of 20 because this is actually b squared. So we have the square root of 20. And then c is the square root of a squared plus b squared. So we'll just add. Okay, square root of a squared. This is the square of a. So we have 16 plus b squared is here. So 10. You'll just have to look at the denominators. This is a squared and b squared. So regardless of which is greater, the first denominator will always be a squared. So that is the rule in hyperbola, unlike in ellipse. Okay, so we have the square root of 16 plus 20, which is 36, and luckily this is a perfect square. So square root of 36 is 6. Okay, we'll now find the vertices. Since the hyperbola given has this equation, we have the quantity of x plus 5 squared, meaning this opens to the left and right. Okay, one opening to the left and one opening to the right. All the movements are on the x-axis. It's horizontal, meaning from the center, we'll be moving to the left for the first curve, and then we'll move to the right for the second curve. That would be the center, or h, negative 5 minus 4. Why negative 5 minus 4? From the center, you will move 4 units to the left. So, negative 5 minus 4. And then just copy k. So we have 2. And then for the second vertex, or v sub 2, we'll have to move to the right. So from the center, we have h, negative 5. If you move to the right, that is addition. So plus 4. Then copy 2. Alright, so this means that we have v sub 1, negative 5 minus 4 like signs. So we combine and then copy the sign. Negative 9 and 2. And then for v sub 2, we'll have negative 5 plus 4 unlike signs. So we have to subtract. 5 minus 4 is 1. And then copy the sign of the number with a greater absolute value. That is negative 1 and 2. So we have v sub 1 and v sub 2. Okay, let's now proceed with the foci, f sub 1 and f sub 2. Remember that the curves are these two. One is opening to the left and the other opens to the right. And the focus or foci are found inside the curve. So here, and here's the other one. So we'll have to move 6 units because it's the value of c. 6 units from the center. So negative 5 minus 6 if you're going to the left, and then copy k, which is 2. And then going to the right, we'll have h, negative 5, plus 6. You have to move to the right. So plus 6, and then copy 2. So simplifying this is f sub 1, negative 5 minus 6 is negative 11 and 2. F sub 2 is negative 5 plus 6 or 6 minus 5. 6 minus 5. That is 1 and 2. So we already have the vertices and the foci. This time we may proceed in finding the equation of the ellipse. Alright, so a while ago, based on the problem, the vertices of the given hyperbola is actually the foci of the ellipse that we are looking for. And then the foci of the given hyperbola is the, or are the vertices of the ellipse that we are looking for. Okay, we reverse this too. So again, this becomes our foci, f sub 1 and f sub 2 for the ellipse, and this becomes our v sub 1 and v sub 2 for the ellipse. Now, take note that the standard form of the ellipse looks like this one. So we have the quantity of x minus h squared all over a squared plus the quantity of y minus k squared all over b squared equals 1. So we'll just substitute based on the given. Alright, so based on what we have solved a while ago, we have the center, negative 5, 2, and then the value of a for the hyperbola is 4, and then the value of c for the hyperbola is 6. So based on the problem, this becomes the value of c for the ellipse. Because according to the problem, the vertices of the ellipse or the vertices of the hyperbola is actually the foci of the ellipse. So C becomes A. Okay? So we just interchange this two. This is 6. Alright, so we'll substitute. We have the quantity of x minus h is negative 5 squared all over a squared. We have 6 squared. And then plus the quantity of y minus k is 2. We have the same center. All over b squared equals 1. If you notice, we already have the values for c and a, but we don't have the value for b yet. So we may solve for the value of b, this time of the ellipse. That will be b is equal to a squared minus c squared. So it's a different formula because we're now talking about the ellipse. Alright, so we have a squared, which is 6 times 6, that is 36, minus c squared is 4 times 4, which is 16. Therefore, b is the square root of 20, and b squared is 20. So if you square this one, you'll just have to cancel the radical. So this is now the quantity of x plus 5 squared minus negative becomes plus all over 6 times 6 is 36 plus the quantity of y minus 2 squared all over 20 equals 1. This will be our final answer. Alright, let's proceed with the checking part. So we know that in ellipse, the greater value represents a squared. So meaning this is a squared, and therefore a is the square root of 36, we have 6. And then b is the second denominator, so we have the square root of 20. And then to solve for c, we have a squared minus b squared, and that would be 36 minus 20. 36 minus 20 is 16. So the square root of 16 is 4. Therefore, c is equal to 4. Now we have the center. This is the ellipse, the one that we have solved a while ago. Center, negative 5, and then 2. Alright, so for us to find the vertices, we'll just subtract 6 from negative 5. Negative 5 minus 6, that is negative 11. and then copy 2. So you can see that here, and that's the vertex of the ellipse. And then for us to find the other vertex, we have to add -5 plus 6, and that is 1, then copy 2. So this is v sub 2 of the given ellipse. Okay, and then for us to find the foci, you just have to add and subtract 4 from -5. So -5 minus 4 is -9, copy 2. And then to find the other foci or focus, we have to add -5 plus 4 is -1, copy 2. So we have proven that the vertices of the given hyperbola are actually the foci of the ellipse, and the foci of the given hyperbola are actually the vertices of the ellipse. 안녕하세요. I know that was a quite challenging problem, but still we were able to arrive at an exact answer. This has been your teacher, Myra Sanzini. 감사합니다.